AB be a tangent line to F in the interval AB and is equal to AB.
I'm sorry, what is it that they want you to do?
Find the equation of the secant line.
Okay, you're right. Part A, secant line. Okay. Secant line means you need how many points? Need how many points? 2. 2 points. Tangent line means you need how many points? Tangent means you need 1. Okay. I need 2 points. How do I get the 2 points? Yeah. F of B. Your B value is what? B value is 1. F of A. A value is what? -1. Plug it in. Sophia, let me know both when you get the answer. That's right. 0 and 0. Okay. To write an equation of any line, besides having a point or 2 points in this case, what else do we need? I need slope. M equals algebra slope or derivative slope? Secant line is algebra. Okay. F of B minus F of A all over B minus A. Okay. We already have A and B, so 0 minus 0 all over what? 1 minus -1? Doesn't really matter. It's going to turn out to be 0. All right, you have everything you need. Which point do you want to pick? The one at 1 or the one at -1? 1. Sounds great. Okay, y minus y1 equals m times x minus x1. The slope is 0, right? So this whole thing's gone. Y is also 0. So what's your final secant line? Y equals to what? 0. Because the x is already gone, right? Multiplying the slope of 0. Okay. So that's the secant line. Here, let me write it in for you. Y minus 0 equals 0 times x minus -1. So all that went to 0. Okay. So that's part A. It said, okay, you got the secant line. What's part B? Tangent line. What does that mean? One derivative. Okay. But this tangent line is very special. Why is it so special? It has to be parallel to what? That line. Okay. All right. Let's do the derivative. F prime of x is. Can you please walk us through doing the derivative of this one, Alex?
Yeah. So you can do the chain rule.
Yeah, good. We're going to write what in the front, Alex?
Well, first you could change the square root to like a fraction exponent.
Yeah.
So you have 1/2 in the front.
Good. 1/2.
And then 1 minus x squared.
Perfect.
Times the derivative of the inside, which is -2.
Did you subtract the power?
Oh, to the -1/2.
Good. Times the derivative of the inner, which is 1 minus x squared?
Yeah.
Good. Then we're going to continue with this. The derivative of the inner is going to give us what, Lucian?
-2x.
Perfect. We are going to simplify. Is that okay? Can I cancel the 2 and the 2? Yeah. So this is going to be a -x on the top. I'm going to rewrite it as a radical because for me it's easier for me to solve when it's in a fraction format. What do I set this equal to? Why 0, by the way? Because the slope of the secant was what? 0. For the line to be parallel, the slope has to be exactly the same. How do we solve for this? Get rid of the bottom. So 0 equals to -x. I mean, x is at 0. Okay. I have a slope for the tangent already. By the way, what's the slope for the tangent? 0. I have a coordinate for the tangent. How do I get the y coordinate? I need a point. I need to plug it back in. F of 0. Plug it back in. That's going to be square root 1 minus 0 square. So that's going to come out to be what? 1. So y minus y1 equals slope times x minus x1. Our point is at 0, 1. So y minus 1 equals slope was 0, x minus 0. Final answer of a tangent line is? Good. Are these two lines parallel to one another? Yeah, one is just slightly higher. Yes, Ryan?
If you have y is equal to 0, do you need to, or y is equal to any number, do you need to go through that process, or can you just put y is equal to, like...
Yeah, you're right. You just write that. But because it's the first one, I want to go through all the motion, because it's not always that easy. You know what I mean?
Yeah. Oh, it has to be a tangent line, so that's
Yeah, you see right away where like it's kind of obvious that things are just going to turn out to be y equals to 1. Yeah, just write that. But I have to write all the step out because all the process will be the same. All right, flip over. Let's do the next one. Similarly, as Edison stated, we need to find first, what's part A? Secant line. That means I need what and what? 2 points. Do we know our f of b, which is 3, right? And then f of 1. All right, plug it in. F of 3 is what, Tony? Perfect. F of 1 is what, Trey? Perfect. I need to find what next? The slope. So the slope is going to be f of b minus f of a all over b minus a. We have everything, right? Square root of 2 minus 0 all over 3 minus 1. So the slope is? Yep, perfect. Which out of those 2 points, which one do you guys want to use? At 3 or at 1? Yeah, because that's easier. Okay. So our equation is going to be y minus y1 equals the slope times x minus x1. So y minus 0 equals rad 2 over 2 times x minus 1. Final answer is going to be y equals rad 2 over 2 times x minus 1. Box it up. That's your secant line. And no, I don't need you to distribute. Oh, shoot, I'm out of space. I write way too big. Okay. All right. Part B. What is part B saying? Now what are you going to do? Find the derivative and set it equal to? Oh, not 0 this time. Rad 2 over 2. All right. The derivative, if you were to rewrite that as a power, what's the power? A half, right? So drop down the power. So 1/2 times x minus 1 to what power? Negative 1/2 times the derivative of the inner. But this time the derivative of the inner just happens to be what? 1, yeah. So I have 1 over 2 square root of x minus 1. Yes? No? Maybe. Set it equal to what, David D? Great. What do we do now? What's our cross multiply? Yeah. Okay. So that means 2 rad 2 times rad x minus 1 equals to 2. Can I drop the 2's from both sides? Yeah. What do we do with that 2 rad 2 and the rad x minus 1? Can I put it under one radical? Yeah. So 1 radical 2 times x minus 1 equals to what over here? 1. How do you solve x? Square both sides. So 2x minus 2 equals to 1 still? Okay. What do you do now to solve x? Add 2 to both sides, and then divide it by 2. Ryan, x comes out to be what, hon?
1. 3. 3 over 2.
3 over 2. That's okay. So x is going to come out to be 3 over 2. How do we get the y coordinate? Plug it back in. All right, Amy Z, help me out. All right, f of 3 over 2. Under the radical, we are going to write 3 over 2. Amy, can I convert the 1 into what fraction? Yeah, let's do that. Which is going to be the square root of 1 over 2, which is really finalized as what? Rad 2 over 2. Do we have everything we need to write our tangent? Yeah. What's the slope again? Rod 2 over 2. What's your y value? Rod 2 over 2. So y minus y1, which is rod 2 over 2, equals the slope, which is also rod 2 over 2, times x minus an x coordinate at 3/2. Okay, example 3. I believe that this may be our last example, A and B. All right. Example 3. Can you please, Marco, help me read the instructions to example 3?
For each of the following, show that the function f does satisfy the hypothesis of the mean value theorem on the given interval a to b. Graph f together with the line through the points a and b, and then find any values of c in a through b that satisfy the equation f prime is equal to fb minus fa over b minus a.
Class, have we worked with this equation before? Yes. Okay. So, part A, it says, prove that your function f of x equals absolute value of x minus 1 from 0 to 3 meets the criteria of the mean value theorem. So, what was David R, Mr. Ross? One of the criteria for the mean value theorem. What do we have to prove?
That it's closed interval.
Closed interval, check. Or not? Yeah, it's from 0 to 3, right? Check. What else do we have to prove? Continuous. Continuous from 0 to 3 inclusive. It's an absolute value function, so is it continuous everywhere? Yeah, absolute value is just a v, right? So definitely continuous everywhere. Okay, last criteria. Differentiable, right? From open interval 0 to 3, like Ryan's pants.
That's already been closed.
I said open interval. All right. So the first two are checked. Is it differentiable everywhere from 0 to 3, not including endpoints? Why are you shaking your head like this? Is there something? Is there a problem location? What's the location?
There's a corner.
It's a corner where? At x equals to 1. Isn't that what the vertex is?
Yes.
Yeah, there's a vertex at x equals to 1. And 1 is definitely in the interval from 0 to 3. So, not differentiable at, that's right, not differentiable at x equals to 1 because of the vertex. Okay? All right. So, did this meet or satisfy the hypothesis? No, did not. Okay? Shame, shame, shame. Now, part B said, let's graph it. So the graph should really back up that part A. So let's see where my space is going to be. Let's do it right here for me. I write way too big, you know. Okay. B, I'm going to graph it out. I do not need a lot of values. I just need it to be from 0, 1, 2, and 3. Let's plug it in. Okay, when x is 0, what, Lauren, what's y? Good. Aiden, when x is 1, what's y?
0.
Perfect. Amy D, when x is 2, what's y? When x is 3, Amanda? That's okay. Katie will back you up. Thank you. All right, let's plot. 0, up 1, close dot. 1, stay at 0. 2, back up to 1. 3, up to 2. All right, close dots at the end. The 2 endpoints. All right. Did this graph support your part A? Yeah, for sure. All right. Part C says find any value at all, okay, in that open interval that will allow us to state that the slope of the tangent is going to be parallel to the secant line. Now, because it failed the theorem, it doesn't mean that it may not have one. It's just not a guarantee. Does that make sense? You may still have at least one, but it's not a guarantee. All right. How do we do part C? What should we do? The formula starts with, I'm going to write the formula because you might want to write the formula every time you do your homework because you want to have it all in your brain before, okay, or exam. All right. What do you want to do first? What side? Left or right? Right side's easier? Okay. What's A and what's B? F of B, so what's B? 3, so f of 3 minus f of A, which is 0, all over 3 minus 0. We found that already from our chart, didn't we? F of 3 is what? 2. F of 0 is? All over 3. So on this secant slope, we have what? 1/3. Okay. What are we going to do on the other side? Yesterday, what did we do? Find the derivative of f of x and substitute c in. Well, it's an absolute value. So what should we do first before we find the derivative? Write it as what? Square root. Piecewise. You're right. Okay, let's write it in piecewise. And you can use the graph to help you out. Can you see this? When x is less than 1 and when x is greater than or equal to 1. I'm writing the equation first and then we'll do the derivative after. Greater than equal to 1 and x is less than 1, okay? And by the way, you can put the equal to either piece. So if I were to use my graph to help me out, when x is bigger or equal to 1, what's the slope? Positive 1. What's the y-intercept? Negative 1. So x minus 1. Yes? No? Maybe so? How about the other side? Tell me what to write. That's right. Negative x plus 1. So now we can do the derivative, okay? The derivative when x is going to be bigger than than 1, I'm sorry, is what? 1. The derivative when x is going to be less than 1 is what? Question mark. Is it ever going to be 1/3? No, never. So would you be able to find any c value? No. Okay. No c values between 0 and 3. Okay. So again, because it did fail the mean value theorem, there's not a guarantee. That doesn't mean you're not going to have some at times. Okay, let's move to B. This is our last example, and it looks like I gave you the whole page. Probably because there are lots of algebra involved. Trig, I know. Okay, part A. Let's do it. We need to do what? Yeah, close. Well, the close one's obvious. I'm not going to do the close, right? What else? Continuous. Okay. By the way, how do we prove that this whole thing is continuous between the inclusive pi to positive pi? I'm sorry, negative pi to positive pi. Because it's two pieces. What must you show to make sure that it's continuous? Yeah, where are they separating? At 0. So to show that it's continuous, especially at 0, because that's where the separation is, I have to find y value, right? And the y value from both pieces will have to be exactly the same. Okay, so let me spell that out. Y values from both pieces must be the same at 0. Okay, let's find the y value at 0. So the first piece, cosine of 0 question mark equals to 1 plus sine of 0. Yes or no? Yeah, okay, so check, continuous. What's our other proof for the theorem? Differentiable, okay. Differentiable everywhere, that's non-including the endpoints. How do we show that it is differentiable everywhere? Again, where do you think the problematic location is? At 0, right? Because cosine is going to be continuous and differentiable. Sine is, but there's a break in between there. So at 0 is where we think the problem is. How do we show that you do have a slope at 0 or not have one? What would you do? Do the derivative. Okay, so let's do the derivative. It's two pieces, so we just do them separately. The derivative of cosine is what? Negative sine of x. Okay, the derivative of 1 plus sine of x is what? Cosine of x. And I don't really care for the domain right now, because I'm just looking to see at x equal to 0. Okay, because that's the only part I'm worried about. They have to have the same slope, do they? The slope, negative sine, plug in 0, what's that? 0. Cosine of 0 is 1. So the slopes are different. So is it differentiable? No. No. So this one definitely, again, does not meet the requirement of the mean value theorem. So that means there should not be any C value. Wrap it up, call it a day. No, okay. We're gonna graph it out to see if our work it's on part A is right. I'm just gonna make a table, okay, from negative pi all the way to pi. So negative pi over 2, 0, pi over 2, and pi. Okay, let's plug it in. So if we are using negative pi, are we using cosine or 1 plus sine? Cosine, okay. So Katie, what's cosine of negative pi? Good. It's been a while. And it's Thursday. And it's a week after spring break, you know? All right. David D. Cosine of negative pi over 2 is? We're about to plug in 0. Which piece? First or second piece? Second, because the second one is inclusive. So 1 plus sine of 0 is what, guys? 1, okay? And then 1 plus sine of pi over 2 is what? 2. And then 1 plus sine of pi is? 1. All right, let's graph it out because it said so. Okay. Here's negative pi. Here's negative pi over 2. I only need 2 values on the top. All right, let's plot it in. Negative pi, I need to go down to negative 1. Negative pi over 2 stays at 0. 0, go up 1. This is a cosine graph. Right, guys? Like that. Then pi over 2, go up 2. Pi, saying at 1. This is, what kind of graph is this one? Sine graph. Okay. Do you think there's a problem location at 0? Yeah, there's some sort of a corner or cusp. I would have to prove it to know which one. Okay, we're almost done. We have part C left. What do you want to do for C? Not do it? F prime of C is F of B minus F of A all over B minus A. You guys already know what F of B is. What's F of B? We found it already on the chart. B, it's pi, right? So 1. So F of pi is 1. A is negative pi. So what's F of negative pi? So negative 1 all over pi minus a negative pi, which leads me to believe that this is 2 over 2 pi. Can I reduce? Yes, okay. I'm gonna hold on right there so we can look at it. Now I need to do the derivative. I think we kind of did that, didn't we? Didn't we do that right there?
Yeah.
Okay. So what are we gonna do with the derivative? I'm gonna take each piece and do what? How do we find the critical? Yeah, I want to find, remember, I want to find C, right? The derivatives are, currently it's in X, would you agree? You can put C in there, or you don't have to, but just know that X would be the value in between negative pi and pi. That's really not a requirement for you to substitute X and C in there. So technically, would you agree that I could rewrite it? This is the derivative, okay? So negative sine of C if I really wanted to, and then cosine of C, like that, to equal to my slope. Our job now is to solve for C. This is the part where it's going to be a bit more difficult. Okay? How do we solve for C? Yeah, we have to take it, and we said equal to 1 over pi on each piece. Is that okay with all of us? Okay, so I'm going to do it up here because I need to write a lot. Negative sine of C equal to 1 over pi. This requires you to know first chapter of first semester. What do you do here to solve for C? Divide both sides by negative 1. So sine of some C value equals a negative 1 over pi. So far, so good. Now you're going to do what? Inverse. All right, use your calculator. Your calculator is going to spit out a decimal. Can you round it to 3 decimal places for me? Negative 0.324. Now, we got to think for a little bit more. Is that the only C location for sine? We haven't gotten to the second half yet. How come not? Remember, your restriction, your interval restrictions were all of the quadrants. Wouldn't you agree? Like the top 2 and the bottom 2, even though they broke it up a little bit. So is that the only location that sine is going to be negative? No. What quadrant is this, by the way? 4. Okay, it's negative. How do I get to another quadrant? What are we going to add? Oh, we add or we subtract? Okay, so let me draw a picture for you. Currently, this is where negative 0.324 is, radians. I want this other spot because sine is negative in quads 3 and 4. Do we add or minus? Okay. But no, if you add, make sure you stick a negative in the front of the angle, right? Okay, so it's really how you want to think of it. So you can go in and add a pi, as long as you know you need to stick a what? A negative in front of that angle. So go ahead and add it for me. What would you get? No. Remember, the angle was from negative pi to 0.
But if you added pi, it'd be on the others.
Right. That's why I said if you add, know that you need to stick a negative in front of it. Or you can go do a positive angle 324 and subtract a pi. That's what I'm saying. If you add, you have to be very careful and stick a negative in front of the angle. Does that make sense? Okay. All right, so give me the second angle. 2.818. So negative 2.818. So these are the 2 angles that will fit in our negative restriction. I'm going to hold on tight before I go any more of the next piece. Right? And again, you can subtract or you can add. Just know that the angle will still be negative. Now that's just that one piece. We have to do another piece. What's the other piece? Cosine of C. I also have to set it equal to, yep, cosine of C equals 1 over pi. So that means C equals cosine inverse of 1 over pi. Go ahead and punch it in. What did you guys get? What's the decimal? 1.247. Someone confirm that for me?
Yes.
Yeah? Okay. That's one answer. Cosine is positive, because that's positive 1 over pi. In what two quads? Here? And here? Okay. Now what do you want to do? Remember, the positive angle was only qualifying from 0 to pi, right? If I add all the way to there, is it over pi? If I were to go, if I add all the way this way, would that be over pi? So would I need to include that last angle or no? No, right? Because if I go all the way past pi, that's past the restriction. So I don't need to add that last one. So that's why this kind of trick one, we have to go back to all of the basic things that we were required to do so. All right, so how many C's did we find? 3, even though we violated our theorem. All right, this is the end.